All right, in lesson number 5, we are going to talk about WPA and WPA2. Obviously, a very relevant discussion to wireless networks today. Maybe not so much WPA, but certainly WPA2. All right. We know that we started with WEP, the wired equivalent privacy, but it was found that WEP was weak, easily breakable, and so on. So the 802.11 committee and the Wi-Fi Alliance worked together to kind of replace that, that protocol. All right. And two solutions emerged, WPA and 802.11i WPA2. These solutions offer authentication, encryption, etc. WPA2 being an 802.11i compliant standard is a little bit more robust. But they were developed at the same time, 2003, we talked about that. So in this lesson, we're just going to talk about what is WPA, what's the difference between personal mode, what's the difference between enterprise mode, and then we'll take a look at the components of 802.1x and WPA authentication and see how that fits into this environment. All right? So the first thing you need to understand is what are the two modes of operation? And WPA determines two different modes of wireless protected access, or what we call Wi-Fi protected access. You've got WPA personal mode, which is going to use pre-shared keys, what we call WPA PSK, or we have WPA enterprise mode, which uses 802.1x and the extensible authentication protocol. All right. Now WPA is actually not supported in 802.11n and AC, at least WPA version 1. There might be some additional versions that are available. As I mentioned, WPA Personal uses the same cryptographic tools as WPA Enterprise. In other words, the encryption process is the same, hiding the data, but it's that initial authentication that's different, right? It uses a shared key to authenticate the client. That shared key is the key that's used in there's actually a four-way handshake that creates the encryption key for that session. Remember, authentication and encryption are always kind of separate from each other. Authentication is usually involves some sort of asymmetric process, whereas the encryption, the bulk encryption, requires some sort of symmetric process. Now, in this case, the shared key mechanism that's used in WPA personal mode doesn't provide per user or per device authentication because every device and every access point that's part of that wireless network uses the same shared key. The key that's used for encryption is unique per user and per session because that gets established dynamically during the process. There's some randomization that occurs in that four-way handshake, but the shared key that's used to authenticate is the same for everyone. So from an authentication standpoint, not as secure, but from an encryption standpoint, very secure. All right. Obviously, we know the primary advantage of WPA Personal is that you don't have to have 802.1x. You don't have to manage a .1x environment. It's also very useful in like voice over wireless LAN deployments that don't require the use of AAA and so on. Because the keys are statically configured and everybody shares the same key, you should definitely use strong keys so that you can protect against dictionary attacks or brute force attacks that somebody might implement to try to be able to associate and authenticate to a wireless domain. All right. Now, WPA Enterprise, on the flip side, uses the base WPA framework, for encryption, all the protection features that you see, but it adds 802.1x, extensible authentication protocol, to base authentication off of certificates, right? In WPA Enterprise, the shared key that's used to generate the cryptographic keys through the four-way handshake is actually derived during the EAP authentication. And we already talked about some of those authentication methods in the last lesson. The EAP authentication process provides AAA features, obviously not existent in WPA Personal. that's going to allow each user device to be individually authenticated. We have policy-based configurations on the authentication IDs that get applied, so we're doing authorization as well, and the collection of statistics and so on, so we're doing accounting. That's what AAA is, right? Authentication, authorization, and accounting. What else should I say? Oh, WPA Enterprise dictates that the authentication phase should be done using, you know, one of those different EAP types that we talked about, whether it's EAP-TLS, PEEP, EAP-GTC, and so on. Excuse me. There may be many other EAP types that are actually supported, but there are only a few different EAP types that you might actually have available to you. All right? All right. Let's talk about WPA2 and kind of do a deep dive into WPA2. We don't really spend too much time talking about WPA because of, you know, it's kind of considered to be a legacy protocol. So we're going to focus our attention on WPA2. As I mentioned in the introduction of this chapter, it's an implementation of the 802.11i security standard. It deprecates the use of WEP. It deprecates the use of WPA. Deprecates the use of TKIP. It supports either 802.1x or pre-shared authentication. 802.11n, 802.11ac obviously support WPA version 2. All right. Pre-shared keys typically used for you know, home office, small office. It's called WPA2 Personal. 802.1x is used in our enterprise type deployments, and that's called WPA2 Enterprise. All right. Now we also use for the encryption process AES, the Advanced Encryption Standard, with counter mode with cipher block chaining. That's the CCMP that you see there. It's an encryption algorithm that's part of also the 802.11i security protocol suite. It's a block cipher. I'm not sure if you guys understand. We don't really need to get into the specifics between stream ciphers and block ciphers, but I guess I can tell you briefly. Block ciphers use blocks of data, or AES has 11 rounds of encryption, right? There's a main round, and then there are 9 intermediate rounds, and then there's a final round of encryption that takes place. And we use various steps within this encryption process. There's XOR operation with a key, a session key, or a round key, I should say. There's a substitute bytes operation. There's a shift rows operation. And then there is a, gosh, what was it called? There's another operation where you're doing some modular math and using Galois fields and stuff like that to encrypt the data as well. But anyway, it's done based on blocks of data, right? So you've got a 128-bit key. You're going to encrypt based on 128-bit blocks of data, whereas a stream cipher is going to encrypt bit by bit. I mean, it's going to go through the process of encryption as the data is being processed, right? Anyway, take CISSP class or take some advanced security classes. You can learn more about that. I actually have on my YouTube channel, if you search for Think Tank, THINQTANK on YouTube, I have my cryptography video posted there. I actually have a lot of videos posted there for the training that I do for a lot of my clients, okay? But anyway, AES is used, actually I'll put the link in the /think tank. Yes, there you go. Lots of cool stuff out there if you guys want to go out and check it out. Don't forget to like and subscribe. Kidding. All right. So AES is obviously used for the bulk encryption process. Very strong cipher. Counter mode, you get into the different modes of operations of these block ciphers. And it has to do with adding I wouldn't say it's kind of a randomization to the process, but it has to do with adding pseudo randomization to the process to make it more difficult for people to to break the information or to get access to the information. Because we are using this cipher, though, because we are using this encryption method, you do have to have updated hardware. You know, maybe that was the case in 2008, 2009, and so on. Actually, in 2003 when this came out. But nowadays, pretty much everything supports this. All right. WPA2 personal mode uses the same shared key and a four-way handshake that WPA uses, but it uses the AES counter mode to actually encrypt and protect those frames. So strong keys need to be used, you know, we want to protect against those dictionary attacks and so on. All right. So let's walk through kind of the process. We keep talking about this four-way handshake, what's happening in this four-way handshake, and how are we managing that process. Now, WPA, I said we weren't going to talk about it, but I guess we will. WPA, as you guys remember from one of the previous lessons, was really a stopgap security measure to replace WEP. But then it was replaced, actually in the same year, by WPA2. It was just a matter of people upgrading their hardware to be able to support WPA2. It used TKIP with MIC. MIC is message integrity, adds message integrity. And it uses the whole concept of the pairwise master key as a basic concept of a four-way handshake to derive the encryption key and then pass those the multicast group key as well. All right. There is a four-way handshake that takes place. The keys are used for the encryption. The keys that are used, for the encryption are derived from the pairwise master key that was mutually derived during the extensible authentication protocol process. That PMK, that pairwise master key, gets sent to the authenticator in the extensible authentication success message, but it's never forwarded to the supplicant because the supplicant derives its own copy of a pairwise master key. All right. So let me kind of walk through the process here. We see four different steps. I'll kind of define what each of these four steps represent. In step number one, the authenticator sends an EPOL keyframe. EPOL stands for the Extensible Authentication Protocol over the LAN, containing a nonce. A nonce is a random number generated by the authenticator that's only used once. That's what nonce stands for, actually. Something used once, all right? And a nonce is authenticator nonce. So the supplicant then generates an S nonce, which is also a random number, and then that gets sent. The supplicant also derives a PTK from the A nonce and the S nonce. All right? That's a temporary key. All right? The supplicant sends an EPOL keyframe containing the S nonce, information elements, which identifies essentially all of the security capabilities of the client, from the association request frame, and the MIC, which is generated from the pairwise master key. The authenticator then derives the PTK from the A nonce and S nonce, validates the MIC in that EPOL keyframe. So we're doing some kind of hashing, and we're trying to verify that everybody has the appropriate information. All right? We're on step number 3, by the way. If the validation is successful, the authenticator sends an EPOL keyframe containing the group temporal key, GTK, the multicast and the broadcast encryption keys. Remember, multicast and broadcast keys have to be kind of generic in a wireless environment because everybody has to use them, because multicast and broadcast are not sent to a specific client. All right? So now we're on step 4. Supplicant sends an EPOL keyframe to confirm that the temporal keys are installed. Once we validated the MIC from this frame, the authenticator installs the PTK for the client. And at this point, the supplicant and the authenticator, they verified that they both have matching pairwise master keys. They both share the same PTK, the same GTK, and so on. All right. Is it really critical for you guys to understand this process? No, not really. I'm not sure why Cisco decided to incorporate so much detail and authentication in this particular course, given that the nature of the course itself. But I know it's very confusing. There's a lot of acronyms and a lot of terminology that's being used to describe this process. But there are actually some great videos on YouTube that walk through these specific processes. As an administrator, Mike, and teach you, you're not going to have to know these steps and so on. But, you know, we do like to teach engineering principles, not just administration principles in these classes. All right. I mentioned the GTK a couple of times. That is a temporal key. That's what the TK stands for. General temporal key. That's used to secure the broadcast and multicast traffic from the AP to all the stations. All right. So when you're looking at the terms here, the GTK, and this is actually something that you can take away from this discussion, right? That there's two separate keys that are used. There's a client key that's used for all the unicast traffic that's unique to that client. And then there's kind of this general temporal key that's used for all the broadcast and multicast traffic that wireless generates that everybody shares, right? The PTK is used to secure that unicast traffic between the AP and the individual station, and the GTK is used to secure that broadcast and multicast traffic from the AP to all stations. All right. Now the GTK may, from time to time, have to be updated. There is a timer, and that timer could expire, or it could be that the station leaves the network and comes back. So there is a secondary handshake. The AP sends the new GTK. It's a two-step process, by the way. The AP sends the new GTK by encrypting it with the station's PTK. And then the station acknowledges the new GTK and replies to the AP and says, hey, I've got this new general temporal key. I'm good to go. Okay? All right. So, in this, we're done with the lesson, but let's go ahead and kind of see if we can summarize some of the concepts that we talked about and take a look at some of the components. So in the first part of this, what I'd like you to do is, and this is a fairly easy one, right? In this diagram, you have a choice between authenticator, supplicant, and authentication server. Which device is which, right? Number one, is that the authenticator? Is that the supplicant? Is that the authentication server? I think you guys know, right? That is the supplicant. Which one is the authenticator and which one's the authentication server? That's easy enough. Obviously, the radius is the authentication server, and the authenticator is the wireless access point or the wireless controller. All right, so that's number one. That's one of the things they wanted you to be able to identify. Next in this discovery, we want to identify, the flow, 802.1x flow over the wireless network. Now, this is a little bit more challenging, right? Because we talked about so many different things. We looked at so many different diagrams and different processes. So what is the process here, right? What is the process? We're trying to fill in these boxes, right? Well, in the blue box, box number one, if you recall, right, the authenticator essentially ignores all requests until the client logs in. Box number 2, which is the one that goes kind of all the way across from the supplicant to the authentication server, that's where the Radius server is actually authenticating the client, and the client authenticates the Radius server. That's what they're trying to depict here. It's kind of a, well, it's not a very good discovery, but we'll walk through it anyway since we've already kind of started to go down the path. The third box, the Radius server passes the session key to the authenticator. That's what, remember we say, hey, success, I was able to identify the supplicant, and by the way, here's the session key, and then the client and the authenticator then start to do their encryption. Now that, by the way it's drawn here indicates that encryption only occurs between the client and the authenticator, which is the wireless access point. That's actually true even in the sense of controller-based wireless, right? Where we have a wireless controller that's controlling the access points. Because there's a secondary protocol that's used between the controller and the access points that includes encryption as well. The Lightweight Access Point Protocol, or LWAP. We'll talk about that later on. All right. What about this slide here? What are the various steps that we see here? This is that WPA2 four-way handshake, kind of the last thing we talked about in the chapter, right? Step number 1, access point sends a nonce, something used once. The client derives a PTK, right? That's box A. The client sends the S nonce, a MIC, and its identity over to the controller. The controller then derives a PTK. Access point sends an A nonce, MIC, and its identity. And then the client sends the PTK done message, the MIC gets sent, and so on. And by the way, that C and D, that's simply where we're installing those temporal keys. All right? All right. So in this lesson, we talked about WPA, the framework that gets created with WPA, how WPA basically works. I mean, the difference between enterprise mode and personal mode and so on. Some of the weaknesses related to WPA. We didn't get into a whole lot of detail. WPA2 incorporates the use of AES for encryption. 802.11i is a protocol, and WPA2 certifies that its implementation. And WPA2 uses that four-way handshake for the key management. And there are two keys that are being exchanged, right? The GTK, the general temporal key, and the PTK, the client-based temporal key. All right, excellent. So we're going to wrap up this lesson here, and we're going to move on to the next lesson.